Assalamualaikum and a very good day to my lecturer. Today we want to present our project which is titled Design and Deployment of a VoIP System for a Small Enterprise Network in a High-Rise Building. This project is for subject BERT 3393 Telecommunication Switching System under supervision of Lecturer Muhammad Hanafiah bin Noor. In this presentation, we will explain about how we design and implement a VoIP system in a small enterprise network inside a high-rise building. We also will show the network design, configuration, and how the voice communication works using IP network. So basically, this project focuses on how traditional communication can be replaced with VoIP system to make communication more efficient and cost-saving. Okay, before we start the main presentation, let me introduce our group members. Our group consists of 4 members. My name is Nur Shazad Udini. My metric number is B122410509 from class 3BRT section 41. Second is Muhammad Aiman Akmal bin Amran. Metric number is B122410455. Third is Wan Muhammad Iqbal Hakimi bin Wan Tarmizi. Metric number is B122410450. And the last one is Muhammad Faiz Iskandar bin Johari. Metric number is B122410475. Also from 3BERT section 41. That's all our group members. Now we will continue with the project explanation. Next, I will explain our project objective. First, object is to design a network topology for a 4-floor enterprise building. Second, we need to segment the network using VLAN to improve performance and security. Third, we integrate VoIP into the existing IP network so that voice communication can run using data network. Next, we configure routing between VLANs so all devices from different floors can communicate. We also apply QoS quality of service to make sure voice traffic has higher priority compared to normal data traffic. After that, we propose some security mechanisms to protect the network. We also analyze the deployment cost to make sure the system is practical and not too expensive. Lastly, we simulate and verify the whole design using Cisco Packet Tracer. So basically all these objectives are to make sure our VoIP system is efficient, secure, and workable in real enterprise environment. Next, I will explain about what is VoIP. VoIP stands for Voice over Internet Protocol. It means voice calls are transmitted over IP networks instead of using traditional telephone lines. This system is more flexible, cheaper, and easier to integrate with existing data network. For our project case, the building has 4 floors, each floor around 14 meter times 25 meter. The current status is the building already has IP network. So our goal is to integrate VoIP service into the existing network. But there are also challenges because voice is very sensitive to delay, jitter and packet loss. So we need to make sure the network is stable and suitable for real-time communication. Next, I will explain about the physical design assumptions and environmental considerations. For physical, for physical design, we assume each floor has user PCs for workstations. We also include IP phones for staff communication using VoIP system. There are workgroup servers provided for local services in the network. For cabling, we use UTP Cat6 cable for all end device to ensure stable connection and good speed. Next, for environmental considerations, we need to plan proper network cabinet placement for each floor. We also consider temperature control for equipment to avoid overheating. UPS backup power is used to ensure the system still running during power failure. And lastly, proper cable management is important to make the installation neat and easier to maintain. So, overall of this section focus on how we design a practical and safe physical network environment for the VoIP system.
Now I will explain the overall topology architecture of our network. Our network uses a star topology where all devices are connected to central switches. The network is divided into 6 VLANs to separate users and services. VLAN 1 is the server room which contains the database server and file server. VLAN 2, VLAN 3, VLAN 5 and VLAN 6 are assigned to users on floor 1 to 4. Each floor includes the PCs, IP phones, printer and workgroup servers. VLAN 4 is the server farm which hosts important services such as the email server, HTTP server, proxy server and firewall. At the center of the network, two Cisco 2960 switches connect all end devices. The switches are connected through a Cisco 2811 router which performs inter-VLAN routing, allowing devices in different VLANs to communicate when permitted by the network policies. Each VLAN is assigned its own 24 subnet, such as 192.168.1.0. For the server room, 192.168.2.0. For floor 1 and so on. This provides better traffic isolation, improves security and simplifies network management. Overall, this topology supports both data and VoIP communication while providing a secure, organized and scalable network infrastructure. Next, I will explain the VLAN design used in our network. To improve network performance, security and management, the network is divided into 6 different VLANs, with each VLAN assigned to a specific department or function. VLAN 10 is dedicated to database and file servers using the IP network 192.168.10.0. VLAN 20 is assigned to floor number 1 users and devices with the subnet 192.168.20.0. While VLAN 30 is used for floor number 2 users and devices with 192.168.30.0. VLAN 40 contains the critical network services including the email server, HTTP server, proxy server and firewall using the subnet 192.168.40.0. For the remaining user network, VLAN 50 is allocated to floor number 3 with 192.168.50.0 and VLAN 60 is assigned to floor number 4 with 192.168.60.0. By separating users and servers into different VLANs, we reduce unnecessary broadcast traffic, improve network security and make network engagement much easier. Each VLAN communicates through layer number 3 routing while maintaining proper isolation between departments. Next, I will explain the VoIP components used in our network. The main device is the Cisco 2811 router which acts as the call manager or Cisco Unified CME. It controls call processing and manages all IP phones in the network. The IP phones are used for internal voice communication between users. A DHCP server is configured to automatically assign IP addresses to each IP phone, making the deployment process faster and easier. The VoIP system also shares the existing LAN infrastructure, allowing both voice and data traffic to be transmitted over the same network. Now, let's look at the VoIP call flow. First, the IP phone receives an IP address from the DHCP server. Next, the phone registers with the Cisco CME router. When a user dials an extension number, the router processes the call and connects it to the destination phone. Finally, the voice conversation is carried using RTP or real-time transport protocol, which transmits the voice packets between the two IP phones. This design provides reliable and efficient internal voice communication while reducing infrastructure costs by using the existing network. Next, I will explain the quality of service or QoS requirement for our VoIP network. To ensure good voice quality, the network should maintain a latency of less than 150 milliseconds, jitter below 30 milliseconds, and packet loss of less than 1%. Meeting this requirement help provide clear and smooth voice communication without noticeable delays or interruptions. To achieve this, several QoS techniques are implemented. First, traffic classification and marking using DSCPEF identifies voice packets and give them higher priority. Second, priority queuing ensures that voice traffic is transmitted before normal data traffic, reducing delay during network congestion. Third, VLAN separation places voice devices in a dedicated voice VLAN, improving both security and performance. Next, bandwidth planning ensures that enough network capacity is available to support VoIP calls. Finally, traffic control helps reduce unnecessary broadcast traffic, allowing the network to operate more efficiently. Overall, these QoS techniques ensure reliable, high-quality VoIP communication across the network. Next, I will explain the security techniques implemented in our network design. First, VLAN segmentation is used to separate users on different floors from the server network. This improves security and reduces unnecessary traffic between departments. Second, access control lists or ACLs are configured to allow only the necessary traffic between VLANs while blocking unauthorized access. Third, port security limits the number of MAC addresses that can connect to each switch port. This helps prevent unauthorized devices from accessing the network. We'll also disable all unused switch ports to reduce the risk of unauthorized physical connections. A firewall is placed in front of public-facing services to protect the internal network from external attacks and unauthorized access. In addition, strong passwords are enforced to secure administrator login credentials. Finally, for management security, we use SSH instead of Telnet because SSH encrypts all communication, making remote device management much more secure. Overall, these security measures help protect the network from unauthorized access while ensuring secure and reliable communication. Next, I will explain the scalability features of our network design. Our network is designed to support future growth and expansion. The VLANs are structured by floor and server groups, making the network easier to manage as more users or departments are added. Each VLAN uses a 24 subnet which provided enough IP addresses for future devices without requiring major network changes. The VoIP system is also scalable, allowing the new IP phone extensions to be added easily as the organization grows. If needed, a dedicated voice VLAN can be implemented in future upgrades to further improve voice performance and security. The router can also be upgraded to a higher capacity router or replaced with a layer 3 switch to support faster routing and larger networks. Looking at the future upgrades, we can introduce PoE switches to power IP phones directly through Ethernet cables. Deploy a separate voice VLAN, implement layer 3 switching for faster routing, add redundant links to improve network reliability, and deploy an IP PBX server for advanced VoIP features.
Alright, for our next slide is financial analysis CapEx. So I will be explain the capital expenditure or CapEx for our purpose telecommunication switching system. So the total CapEx for this project is around 31,500 ringgit. That cost covers all the hardware installation and initial setup required before the system can start operating. The large cost is 14 Cisco IP phones, which costs 14,000 ringgit because every staff required an IP phone for communication. And we are also allocate 1,500 ringgit for a Cisco 2911 router and 2,400 ringgit for the two Cisco 2960 switches to provide network connectivity. So that beside, we are include that server setup, which is UTP Cat6 cabling, rack and panel installation, and network UPS to ensure that network is stable, organized and protected from our interruption. So finally, the final 3,000 ringgit is allocated for installation and labor, while 1,200 ringgit is provided for staff training so that users and administrator can operate that system effectively. So the overall that CapEx investment ensures the system is fully installed, reliable and ready for long-term operation. So we are going to our next slide. Alright, we are going to our next slide about final analyze, but we are going to OPEX. So the total operating cost around 830 per month, which is equivalent to 10,000 ringgit per year. For the cost cover the ongoing expenses for required to keep the system running efficiently. So the highest annual cost is maintenance and support that amounted to around 2,500 ringgit to ensure that system remain reliable and any issue can be resolved quickly. So we are also allocate 2,000 ringgit for network administration, for 1,500 ringgit for device replacement reserve, and 1,200 ringgit for electricity usage, and 1,000 ringgit for software and license renewal. So in addition, 800 ringgit is allocated for staff training, 600 ringgit for network monitoring tools, and 400 ringgit as a contingency fund for unexpected expenses. And the overall for OPEX budget ensure that the network remains stable, secure and will maintain it while supporting continuous operating throughout for the year. Thank you. We are going to our next slide.
Alright, next is the simulation result for the VoIP system. This simulation demonstrates a successful phone-to-phone call between the IP phone on floor 1 and the IP phone on floor 2. Both phones are successfully registered with the Cisco CME router, allowing the call to be established without any issues. This result confirms that the VoIP configuration and communication between different VLAN are working correctly. Next is another VoIP simulation result. This simulation shows a successful phone-to-phone call between the IP phone on floor 1 and the IP phone on floor 3, even though the phones are located on different VLANs. The call is connected successfully through the Cisco CME router. This confirms that the VoIP system and inter-VLAN routing are working properly, allowing reliable communication between different floors. Alright, this simulation shows a successful phone-to-phone call between the IP phone on floor 1 and the IP phone on floor 4. The call is successfully established even though both phones are located in different VLAN. This proves that the Cisco CME configuration, inter-VLAN routing and VoIP service are functioning correctly.
enabling seamless communication across all flows in the network. Alright, next is the simulation result for a phone-to-phone call between flow 3 and flow 4. The call is successfully connected, showing that both IP phones are properly registered with the Cisco CME router. This confirms that users on different flows and VLAN can communicate smoothly through the VoIP network. Overall, the simulation proved that our VoIP configuration is working successfully across the network. Alright, next, this slide shows the connectivity test result using the ping command. We tested communication from the flow 1 PC to the flow 2 PC, flow 3 PC, flow 4 PC, and the database server. As shown in the result, all devices successfully replied to the ping request, with only the first request timing out due to the ARP process. After that, all packets were received successfully with 0% packet loss. This result confirmed that the inter-VLAN routing is functioning correctly, allowing devices in different VLAN to communicate successfully across the network. Next, this slide shows the ping test result between the user PC and the servers. The tests include connectivity from the flow 1 PC to the email server, flow 2 PC to the database server, flow 3 PC to the database server, and flow 4 PC to the database server. As shown, all devices successfully received replies after the initial ARP request with 0% packet loss. This confirms that the PC can access the required network service across different VLAN. Overall, this result verified that our inter-VLAN routing and server connectivity are functioning correctly, ensuring reliable communication throughout the network. Next, this slide shows that the web server access test from PC on different flow. The results show that the PC on flow 1, flow 2, flow 3 and flow 4 can successfully access the server using a web browser. The Cisco Packet Tracer web page is displayed correctly, confirming that the HTTP service is available. This proves that all user PC can communicate with the server across different VLAN, and the web server configuration, inter-VLAN routing, and network connectivity are working successfully. This slide shows the configuration verification for the router and switch. The show VLAN brief command confirms that all required VLAN has been successfully created and the switch port are assigned to the correct VLAN. The show IP interface brief command verify that all router interface and sub interface are configured with the correct IP address and are in the up state. This verification result confirms that the VLAN configuration, router interface, and network connectivity are correctly configured, allowing communication between all VLAN and supporting both data and VoIP service. This slide shows the Cisco CME router configuration for the IP phone. The configuration includes 4 ePhones, each assigned with a unique extension number from 1001 to 1004 and registered using their MAC address. The telephony service configuration set the maximum number of ePhone and directory number. while the auto assign feature automatically assign the extension to the registered IP phone. This result confirms that all IP phones have been successfully configured and registered with the Cisco CME router, enabling user to make and receive VoIP call successfully. This slide shows the IP configuration for the PC on each floor. Each PC has been successfully assigned the correct IP address, subnet mask, and default gateway based on its VLAN. For example, floor 1 use the 192.168.2.0/24 network. Floor 2 use 192.168.3.0/24. Floor 3 use 192.198.5.0/24, and floor 4 use 192.168.6.0/24. This result confirms that all PC are configured correctly and can communicate through the router, enabling successful connectivity between different VLAN and access to network service.
Alright, we are going to our last slide for discussion and conclusion. Alright, for discussion, that Voip network successfully the design using Cisco 2811 router and 2960 switch with 6 VLAN for better organized and security. For the simulation, they show how the network can do inter-VLAN communication, DHCP, and Voip call. For QoS, make voice more clear and stable. That system is cost that effective and can save cost for long term, and also easy to expand and improve in future. So for the recommendation for this VLAN and Voip, that a company should to implement Voip system because it's that practical and cost saving. So the voice VLAN should be added for better voice traffic control. Third, PoE switches recommended to easy IP phone installation and power. That strong security like SSH, DHCP, snooping, and firewall should be used. And then backup power and redundancy needed to improve the system reliability. The last, network monitoring should be done regularly to maintain call quality. That our recommendation. And for the conclusion, the proposed Voip design is successful. So meet for assignment requirement and so stable for enterprise network implement. So our slide from us. Thank you.